Here we are with Unit 7, Lesson 5, negative exponents with powers of 10. Let's see what happens when exponents are negative. We haven't dealt with this much yet, but here we go talking more about those negatives. What we want to recognize first with the number talk is what's that exponent? It sounds kind of like a game show. So we're going to solve these each mentally, and I'll go ahead and write down the answers to them, but mental math is where we're going to work with this. So mentally, we have 100 divided by 1. I can just think about that as 100. And I know that 100 is equal to 10 to the what power? I know that 100 is equal to 10 times 10. So that's equal to 10 to the second power, which tells me that x must be equal to 2. For the second one, 100 divided by something equals 10. Well, since I know that 10 times 10 is 100, then 100 divided by 10 is equal to 10, 1/10 of that value. So the first one we see 10 times greater is the answer. So I have to go 10 times greater than this base. The next one I have to see that the base times 10 is just that value there. The next one we're looking at for power that's raised to the 0th power. Remember that 10 to the 0 and any power or any base that goes to the 0 power is equal to 1. I know that my top number, numerator, has to be equal to the denominator. So x is equal to 100. And then finally, the last one, the x to the 10th power, or x to the, 100 thousandths is equal to what power of 10? This one might be helpful to recognize this, that 100 is 10 times 10 divided by 1,000, which is 10 to the 3rd power. And then what I'm left with is by division, I know that 10 divided by 10 is 1. 10 divided by 10 is 1. So we're working off of this quotient of powers. And what I'm left with is just a single 10 in the denominator. Well, that would actually just be 1/10. So when we look at this value and we talk about what am I doing with 10 to the x power, what would the value of x have to be? We'd have to think about how is that value set up to be able to equal this solution of 100 divided by 1,000. And that's what we're going to be figuring out today. What I will tell you is this. X has to be equal to -1 in this case, and we'll talk about that in this lesson as we get going. We're going to move up here, and it looks like I'm going to have to clear all that. There's a new toolbar, so I'm learning how to use it. Section 5.2, negative exponent table. We're going to complete this table to explore what negative exponents mean. First, looking through it, I see that we have using exponents at the top. We're going to write those exponents as decimals and as fractions. The next thing that I notice is that I have these arrows that are working from left to right. And I see every time I move from one cell to the next, I'm getting 10 times greater. That means on the bottom, I have to be considerate of that piece. There's a question mark. We're looking for a pattern that happens. As I get from right here, 10 to the 1st power to 10 to the 2nd power, I recognize 10 times greater has taken me from 1 times 10 to 1 times 10 times 10, 10 times greater, right? And then 10 to the 3rd power is going to tell me 1 times 10 times 10 times 10. Okay, so what I see as a pattern right there is that I'm just going to increase by having one more power of 10, which in the same token means that if I go the opposite way to the right, I should be able to take off a power of 10 because I see 3 tens, 2 tens, 1 10. So this next one at no tens, I just have a 1, I should be seeing 10 to the 0 power because I go from 3, 2, 1, 0. So it seems logical then under that premise that if it's 10 to the 0 power, we should be equal to 1. The next step to that is I should see if that pattern continues, 10 to the -1, 10 to the -2, and 10 to the -3. Awesome. Let's go ahead and follow in the next step, and let's see if we can figure things out. As we're talking about a decimal, I notice the pattern that we go from 1,000, 10 to the 3rd power is 1,000, 10 to the 2nd power is 100. 10 to the 1st power is simply 10. And you might be asking, why are you writing 0.0? Well, because it says as a decimal, and so I need to include it at least the 10th place. The next step where I'm looking at this is I see 1,000, 100, 10, 1. I believe I'm getting 10 times smaller, and so the next logical step would be 1/10, 1/100th, so I'm good right here, and then 1/1000th. And that matches up with my fraction here on the bottom. So now by this point, if you haven't caught on, what's actually happening right here is we're working with these powers of 10, and we're seeing how that power of 10 changes from cell to cell to cell. In the numerator, or excuse me, in the top section up here, I got 10 times larger every time. That means down here I have to understand how am I going to make this the opposite of that, or 10 times smaller. What we have is this thing called the multiplicative inverse, where it talks about if I multiply by 10, then my multiplicative inverse with this is to take its reciprocal and undo it. So multiplying by 10 can be undone by multiplying by 1/10. So if I consider those pieces and talk about that fact, that should follow through that this box right here, 10 to the second power, is 1/10 the value of 10 to the third power. And I can see that holding true with fractions actually quite well. 1,000 is written as a fraction of 1,000 divided by 1. 100, 100 divided by 1. 10 divided by 1. 1 divided by 1. And then when I go to multiply that by 1/10 again, what I see is that 1 divided by 10, or 1 times 1/10, is equal to 1/10. And then again, multiplying by 1/10, a tenth of a tenth is a 100th, and a tenth of a 100th is a 1,000th. So as we move forward towards the left, we see that each number is being multiplied by 10. What is the multiplier as you move to the right? The multiplier is equal to 1/10, because I'm going to be taking a value that's 10 times smaller every single time. So how does each of these multipliers affect the placement of the decimal? Times 10 does what to the decimal? Well, we see that the decimal, when we multiply by 10, it moves the decimal as we work from right here, working our way from left to right. We see that that decimal is slowly moving to the right. So times 10 increases the value. Moves decimal to the right. Okay. So times 1/10 is something that's going to decrease the value. And we talk about decreasing the value by a factor of 10 by moving the decimal left. So we see that as we decrease, we actually follow the same pattern as the number line, where as we decrease, the numbers moving left, as we increase, the numbers are moving right. So there's the thought for that section. Let's go on to the next part of this, where we talk about number 3. It says, use the patterns that you found in the table to write 10 to the -7th as a fraction. Well, what we noticed with that is with our patterns, we went from 1,000 to 100, so on and so forth. We kept going down. We went down to the point where we were at, the fraction on here is 1/1000th, and we see that that's 1 divided by 10 to the third power. And so when we write this one down from 1/1000th, we could take our next pattern, or our next value would reasonably be 1 divided by 10,000, and then 1 divided by 100,000. And I can pretty much hear you saying, well, no, hold on, why don't you just keep going down by powers of 10? Well, the powers of 10, what we can recognize is that we're seeing that each of these fractions were the result of taking the previous number, dividing it by 10 to the third. This next number right here would be where we would see dividing by, let me switch my color. This is the same thing as 1 divided by 10 to the fourth power right here. And then 1 divided by 10 to the fifth power. with this one. Sorry, it's getting messy. I'll do a better job. And so if we continue going on with this, when we see something like this, 10 to the negative seventh power, we should ultimately see this. The reciprocal of 10 to the negative seventh is 1 divided by 10 to the seventh. So keep that in mind, what I just said about reciprocal. That's where we're going with this, okay? So if we're going to write 10 to the negative fifth power as a decimal, we need to consider that same concept, that everything is multiplied by 1. So we have 1 times, remember that negative exponent, we saw that we were actually multiplying by a factor of 1/10. So we would multiply that value by 1/10 times 1/10 times 1/10 times 1/10 times 1/10. And what you'll notice, hopefully, is how I got from this value of 10 to the negative seventh over here to 1 divided by 10 to the seventh. And then what I see here is if I multiply all my numerators, I get 1. If I multiply all my denominators, I get 10 to the fifth power in the denominator. And so I know that 1 divided by 10 to the fifth power is the same thing as 10 to the negative fifth power. What we need to start recognizing is that negative exponent, when you take a number and you raise it to a negative power, what you're going to see with that is you need to start thinking about this in terms right here as not negative, but you need to start thinking about the multiplicative inverse or the reciprocal. And that's what we really need to think about. So now I think about this one, we're going to write 1/100 millionth using a single exponent. Well, we keep the 1 the same, but then we can take 10 and write that 10 and look at the powers of 10 that are given here. We know 1 times 10 8 times would be that value of 100 million. As a single exponent, right now this is not a single exponent because of the invisible exponent in the top. So we would have to say that this is 10 raised to the negative 8th power. Excuse me. So what use the patterns in the table to write 10 to the negative nth table as a fraction, we can recognize that that will be a reciprocal of 10 to the nth power. Excuse me a minute. All right, let's take this a step further then. Let's talk about this in terms of the exponent rules. We'll clear that. And we'll notice a few things in the exponent rules. As we talk about these powers of 10, we talk about the first one. This is the power of a power. That power of a power is telling me that I'm taking 10 times 10. And I'm going to do that 3 times. So there's 3 groups of 10 to the second power. And where I see that at, and where I see 10 times 10, I see that right here just in the denominator, in the first one. But I see that again down here with just 10 times 10. There's 10 to the second power, there's 10 to the second power, and there's 10 to the second power. So I see this 10 to the second times 10 to the second times 10 to the second. I see 10 to the second power 3 times. So if I call this one right here, I could say this one is equal to 10 to the second power raised to the third power. Done with that one. The next one, I see the same thing. I see 10 being raised to the second power. I need to see 10 times 10, but then I see that reciprocal or that negative exponent, which tells me, hey, I'm looking for a reciprocal. So I need to be flipping that over, inverting my fraction. By inverting that, what I'm saying is if I see 10 to the second power raised to the negative third power, it looks like this. Currently, I want to change that to a reciprocal that says 1 divided by 10 to the second power. So take my reciprocal first and then justify my power to a positive exponent. And when I think about it this way, I'm looking for 10 to the second power only in the denominator, and that gives us this one right here on the top, 10 to the second power, but we're inverting it, raising it to the negative third power. Now that's going to make the next one look just a little bit different. I'm going to go and switch colors so we don't lose it. 10 to the negative second power Likewise, we do the same thing, 10 to the negative second power raised to the third power tells me that I need to take the reciprocal of 10 to the second power and make that 1/10 to the second power first, and then square that value. So what I'm looking for here is I'm looking for 1/10 times 1/10 in the denominator. Excuse me, no, not sorry, in the denominator, in the value. So I'm looking at this as saying 1/10 twice, and then cubing it. So I would see that grouping 3 times. That would make this one right here, second one down, my value that I'm looking at for this piece. Okay, the last one, which actually looks quite different from the others. We have a negative times a negative. Just a quick thought with this. First thing, we want to look at the reciprocal right here of 2 to the or 10 to the negative second power, which means that I have the reciprocal 10 to the negative 2 over 1 is being raised to another reciprocal. So we have to think about flipping and flipping. So what we really need to consider here is this. We take our reciprocal first of 1/10 raised to the second power. And then I need to take my value and take the reciprocal again, which means that now instead of being a numerator, it's a denominator. And so I end up with 1 divided by 1/10 times 1/10. And that will become, or that'll happen 3 times. So that'll be this last one straight across from it. I'll just do equals because it equals this one. All right. Remember to send your questions to me, email them to me so that I can chat with you and we can talk about it. Next one, right? 10 to the second time to the negative third is a power of 10 with a single exponent. Be prepared to explain your reasoning. This is where life gets really easy with the exponent rules. We remember from an exponent rule, when we have power raised to another power, we can simply take that power of 2 and multiply it by the power of negative 3 to tell us that we have 10 to the negative 6th power. And that would be our single exponent. And the reason for this, that we would be able to call it this, it says write 10 to the second raised to the negative third as a power of 10 with a single exponent. Be prepared to explain your reasoning. What we'd have to say is that the power of a power rule ends up using the product of the exponents to be able to simplify the expression. We're going to match some more expressions with some repeated multiplication in the same way. And so we look at this one, we see 10 to the second power divided by 10 to the 5th power. We see no negative exponent, so nothing's going to move. This one matches here. When we look for another one, 10 to the second power over 10 to the negative 5th power, 10 to the second power is positive value, is a positive exponent, so we don't have to change. But we have to be thinking about the reciprocal of 10 to the negative 5th. So it might be helpful to recognize 10 to the second power doesn't change, but 10 to the negative 5th power is the same thing as 1/10 raised to the 5th power. So this one right here will come to the bottom. 10 to the negative second power tells me that we're going to take 1/10 to the second power and divide it by 10 to the 5th power. So this one's actually straight across from it. And then our last option, it should be pretty obvious now that I see negative in the numerator, negative in the denominator. What I'd like for you to think about with this is that as reciprocals, these values are going to look like this. And what's pretty interesting about this, all of this, is that we can still use our old rule, or not our old rule, our quotient of powers rule, to recognize that we can go ahead and just do subtraction of the exponents and take 10 to the negative second power and subtract the negative 5th power. which ultimately means that I'm removing more negatives than I actually have. So I can take away 2 of them, that gets me back to 10 to the 0 power. But by removing -5 from -2, I actually end up with a positive 10 to the 3rd. So there's my single exponent. Be prepared to explain your reasoning. What we would recognize with this is, say, quotient of powers. And with that quotient of powers, we can say that x to the m divided by x to the n equals x to the m minus n. And there's our rule that would support that single exponent rule. Interesting thing with this is when you take a fraction such as 1/10 times 1/10, that would be 1/100th divided by 1/100,000th. When you divide by a fraction, you're actually going to be getting a larger value. So it makes sense that we have these rules for problems like this to be able just to say, the subtraction piece of it, because or the subtraction of the powers, because these powers, when we're dealing with them, we have to write reciprocals all the way through. It really doesn't make a lot of sense to have to write those numbers all the way out. It's inefficient. We have a little bit more matching. This one I'll make sure that we go pretty quickly. We see both of these as product of powers. 10 to the 4th times 10 to the 3rd tells me that I can use a product of powers to match up 4 plus 3. I see a group of 4 here and a group of 3 here. That shows me all that multiplication. This is the first one, 10 to the 4th times 10 to the 3rd. My next problem that I'm after with this one, 10 to the 4th times 10 to the -3rd. This is like saying times 1/10. Whoops, not 1/3. 1/10 to the 3rd. Remember, reciprocal of the base, and then justify the exponent. And so we see 10 to the 4th times 1/10 to the 3rd. That comes here to the top. 10 to the -4th power is going to be our reciprocal, 1/10 to the 4th times 10 to the 3rd. So this one is straight across. And then you guessed it, for the last one, we're going to match this last one again with something that is not right across it or anywhere convenient for an arrow. But we see that we're dealing with 10 to the -4th is the same thing as 1/10 raised to the 4th power, or the reciprocal of 10 times 1/10 to the 3rd power. We recognize those pieces. So with all that, we can take our little, not necessarily shortcut, but our exponent rule of 10 to the -4th times 10 to the 3rd, product of powers. Which says that if I have 2 powers that I'm multiplying together are equal to the base with the sum of those exponents, because they have the exact same base, it ultimately comes out to just repeatedly multiplying x multiple times. So with this explanation, well, that was crazy, 10 to the -4th plus the 3rd would give us a value of 10 to the -1st power. And there's our justification. Okay. We're going to go ahead and skip over this next section and just get to our summary and just get to the real meat of what this is. The negative exponent rule tells us this. When we multiply a positive power by 10, or of 10 by 1/10, the exponent decreases by 1. Really important to recognize. Multiplying by a positive power of 10, positive power of 10 by 1/10, we're going to decrease the exponent by 1. This is true for any positive power of 10. We can reason in a similar way that by multiplying 2 factors that are 1/10 decreases the exponent by 2. So we see that same piece with that. It means that we can extend the rules to use negative exponents to make a reciprocal statement right here, which means that 10 to the 2nd power is 2 factors that are equal to 10. So when we have 10 to the -2nd power, we have 2 factors that are 1/10. So again, what we're looking at here is we want to think about the base when it's raised to a negative power. We want to be thinking about, I want the reciprocal of the base first. And then I can raise it to its power because I'm justifying that negative exponent, which in reality, I guess you could argue that if a positive exponent is repeated multiplication, a negative exponent would have to be repeated division or repeated multiplication of the inverse. To continue this on, we have a general statement that says this is what I really need you to get from here, and that's what I was just explaining. When you see any integer n or m, right, in general, we've developed a rule that's true for all integers, is when we see an exponent that is negative, we want to take the base as a reciprocal and then raise it to that same power, but we're looking for that power to be then a positive number. There's several other examples here down below this. I'll have you go ahead and take a look at those, read through the rest. Don't forget that we can still apply all of our other rules of product of powers, quotient of powers, and power of a power to our negative exponents, and we'll still get the same outcome. Thanks for checking in. I know this is pretty heavy. Please reach out to me when you're stuck on this. I'll see if I can do a better job of explaining to you. Have a great day.